Another video demonstrating the manufacturing process of their humanoid robots was released by the well-known Chinese business X Robots. This new video, like all of the company's others, has gone viral and is a huge hit. As a reminder, experts are working on improving humanoid robots at the X Robots factories in the seaside city of Dalian, with a special emphasis on face expressions and emotional responses. Androids represent the most complex direction in robotics, said Lei Boyang, CEO of X Robots. A single model of this type costs 1.5 to 2 million yuan, or around $280,000, and takes 2 to 4 weeks to manufacture. Humanoid torsos in different states of assembly are strewn across the workshop, along with silicone face masks, hands, and feet. X Robots, a well-known name in the industry, was founded in 2013 and bills itself as a high-tech company that specializes in the development, manufacturing, marketing, and maintenance of intelligent bionic humanoid robots. The humanoid model's main function for the time being, though, is to operate as living displays at the EX Future Science and Technology Museum, which is situated on the grounds of the EX Robots facility. Forschungs Centrum Informatica in Karlsruhe, a novel robotic hand that can make delicate and accurate movements with a variety of objects, was first demonstrated at a meeting. The European project DexSmart included research on the creation of the manipulator with artificial tendons. It is simple for humans to handle various objects, such a paper cup of juice, but it is really difficult for robots to do so. With more actuators than the muscles in a human hand, researchers have created a mechanical hand that can effortlessly complete these activities. With just one tiny electric motor and a 20 centimeters long tendon, the robotic hand can lift 5 kilograms objects at a speed of 30 millimeters per second thanks to incredibly strong polymer tendons. Similar to a human finger, each robot finger is made up of 3 parts that are managed by separate tendons. The new manipulator can easily lift big objects and handle delicate objects like a chicken egg with care. These devices can be employed in surgery, human-machine collaboration, and sophisticated repair work in dangerous settings. With its advanced sensing and motor systems, one of the main robots created for this research can do complex manipulation tasks that call for human-like dexterity. By imitating human hand and arm movements, this robot is intended to improve the capabilities of service robots, increasing their effectiveness and adaptability in a range of applications. The DexSmart project intends to push the limits of what service robots can accomplish by integrating cutting-edge technology like multi-axis arms and 360-degree sonar detection, especially in settings that need a high degree of dexterous manipulation. Marco Tempest, who works at the nexus of magic and technology, refers to himself as a cyber illusionist. Marco Tempest showcased the skills of the robot EDI at a robotics-focused TED conference. Tempest's newest Technoid, a gregarious Baxter robot named EDI, Electronic Deceptive Intelligence, wonders what makes artificial intelligence different from human intellect. According to Tempest, the mechanical robots of the Victorian era that performed mental tasks were little more than illusions in contrast to the intelligent robots of today. With 2 7-axis arms and a 360-degree sonar detection system, EDI, on the other hand, is extremely realistic. The idea of building a mechanical version of ourselves intrigues us, according to Tempest. We are afraid that the ideal robot would be indistinguishable from a person. For instance, we are unable to predict the behavior of robots because we are unable to read their facial features. But the opposite is also true. EDI concurs. Humans are illogical and unpredictable. I genuinely don't know what you guys will do next time. AALI is a sophisticated service robot created for a variety of challenging jobs by the House of Living Labs at the FCI Research Center for Information Technology. Because of its active torso, HALI's shoulder height may be adjusted from 96 to 124 centimeters, making it 142 centimeters tall. With 49 active degrees of freedom, the robot can maneuver with extreme dexterity and accuracy. AALI is capable of independently navigating and interacting with its surroundings thanks to its 360-degree sonar detecting technology. Its cameras offer artificial vision for interaction and object recognition, AALI can execute activities requiring delicate handling by bending and reaching the floor thanks to its bimanual manipulation capabilities. AALI was first recognized for its abilities as a robotic barman and pastry decorator, but it can also help with healthcare duties and other service-oriented applications. The goal of the robot's development is to improve human-robot interaction in real-world situations and attain human-like dexterity. In partnership with Ritsumeikan University and auto parts company Denso Corp., the Japanese National Agriculture and Food Research Organization has created a harvesting robot prototype that can pick fruits as quickly as a human. The workforce in the Japanese fruit tree business is getting older and fewer in number. A prototype automated fruit-picking robot was created to gather apples, Western pears, and Japanese pears from V-shaped trees in order to address this issue. The prototype robot uses unmanned ground vehicles to navigate between trees and uses its 2 robotic arms to collect fruits. An automatic fruit storage system receives the gathered fruits. The automated fruit storage system replaces the filled container with an empty one while the harvesting robot continues. Naro claims that the prototype picks 1 fruit roughly every 11 seconds, which is comparable to a human speed. LEO, a mobile service robot created by F&P Robotics Edge, is intended to help medical personnel in a variety of environments, such as hospitals, assisted living facilities, and rehabilitation centers. LEO, which is about human height, has a 360-degree sonar sensing system for safety and environmental awareness, a functional arm for gripping and moving items, and autonomous navigation capabilities. Through speech and touch interfaces, LEO engages with patients, offering company, promoting activities, and helping with everyday duties like item delivery. By carrying out these duties, LEO contributes to a 3 to 4 hour daily reduction in the workload of healthcare personnel. By patrolling facilities to find odd activity and any dangers, LEO also improves safety. LEO is adaptable to unique requirements and easily connects with a variety of tools and systems, which eventually raises the standard of care by freeing up medical staff to concentrate more on patient care. The 5th iteration of the Lauren series, Lauren V, is a hexapod robot created by the Fraunhofer Institute in Germany. It is made to carry out work in dangerous and difficult-to-reach places for people, like scientific research, rescue missions, and other situations needing a high degree of mobility and stability. The robot can navigate across complicated and uneven surfaces thanks to its 6 legs, each of which has 6 degrees of freedom. Because Lauren V is equipped with a variety of sensors, including cameras, laser scanners, and force sensors, it can precisely manipulate objects and traverse its surroundings. These sensors aid Lauren V in gathering information about the terrain and identifying risks or objects, which is especially important during research or rescue missions. After watching this video, let us know what you enjoyed most in the comments section. Please remember to like and subscribe to our channel if you liked the video. I'll see you later.